Hello class, welcome to section 9.2. We'll continue our work with percentages, and specifically we're going to get into interest and then compound interest. So as always, a few definitions. Interest is the money paid to use a lender's money. Those who have bank accounts or have taken a loan are familiar with interest. As it says, interest is what you're charged for either borrowing someone's money or lending someone's money. Principal is the initial amount paid to an account or the initial amount of a loan, for example, which does earn interest. The rate is the percentage of your deposit that is paid, either as the lender or the borrower. And that's usually given in terms of an APR, an annual percentage rate. And the simple interest is calculated once a year on a particular value, whereas future value is the amount in an account after a set period of time, sometimes referred to as a future amount. And then sometimes the initial amount is often called the present amount at times. And then compound interest is interest on interest, meaning that in one particular cycle, interest is added onto the principal. And then from that new amount, interest is taken again. So instead of like simple interest, where over 1 year your interest is calculated on a bank account, for example, compound interest would be calculated over, say, every month. Then after 1 month, whatever is earned in interest is added back onto the principal, and then that is used to calculate the next cycle of interest. Which is why, of course, compound interest grows much faster than simple interest. And a logarithm is the inverse function of an exponent, or an exponential. And we're going to be using it in particular to find values of unknown exponents. So most of this section comes just from the types of questions you can get. So for example, what is the interest of an account where you deposit $550 in at 2.5% for 5 years? Assume simple interest. So if I'm just asking for interest, we're using our simple interest formula, I equals PRT. Where the P stands for principal, R stands for the rate as a decimal, that is, and then T stands for time. And it's very important that R is always entered in as a decimal, as opposed to a percentage. So in this case, I'll say 550 times 0.025 times 5. In other words, you wouldn't want to say 2.5. That would throw off your calculation very, very much. And then you do the math, you end up with 68.75 as the interest earned. And then taking that one step further, what is the future value of the same account? Future value means that not only are you calculating what the interest is, what's that new account actually worth at the end of this 5-year period? And for that, we have a couple options. You can either take what you have in interest and add it back onto the original amount, or you can use a new formula, this one here, A equals P times the quantity 1 plus RT. And here again, P, R, and T stand for the same thing, a principal, a rate, and our time. So entering in my formula gives me 550 plus 1 plus 0.025 times 5. Do my order of operations. It gives me 1 plus 0.125, so I have 1.125 times 550, which comes out to be 618.75. And as I said, you can either add your 68.75 from this calculation to the original amount of 550, or put it into this formula. So an account earns 10% interest compounded annually. How much is left after 3 years? And as was stated before, here is how compound interest works, as opposed to simple interest, where your principal over 3 years would not change. Compound interest, the future value, whatever is made, is added back into the formula. So for example, we start at $2,000. After 1 year, our interest at 10% is $200, and so that's added to get $2,200, and that becomes our new principal. Then, using that same future value formula, my new principal is $2,200 as opposed to $2,000. If it were simple interest, this $2,000 would be the same for all 3 of these cycles. So again, following the same formula, now I have 2420, and again, it just cycles into the next set of calculations. So we end with 2662. And our annual compound interest formula comes in as this: A equals P plus 1, P plus 1 plus R, P times 1 plus R, to the T power. Where again, R is our rate and T is our time. And notice that's annual compound interest. So in other words, if a question will tell you, if the interest is calculated annually, then we use this particular formula, which is where we got all of these, what we use for all these values up here. My rate is 10%, so 0.1 is R, 3 is T for 3 years. Then when you do the math, and of course you make sure you do order of operations, so you say 1.1 to the 3rd power first, then times 2,000 will give us our 2662. In general, here's our compound interest formula. Now this time, you notice a new variable, n, and just to be clear, let's put these in. This is our principal, is our P, R is our rate, T is time, and our N is the number of times compounded per year. So as opposed to the last question, when it said we have annual compounding, so it compounds once a year. When it says we compound every month or every day or every week, for example, then our n changes. And then taking that further, is this another formula that we can use, our continuous compounding formula. So if it's told to us that the interest compounds continuously, and it will use that specific phrase, compound continuously or continuous compounding, we use our A equals PE to the RT power formula, that is. And then E, if you're not familiar, is called the natural exponential, and E is always 2.7182, and then it's a non-terminating, non-repeating decimal. As far as your calculations are concerned, using the estimation 2.7182 is fine, and then your calculator, if it's scientific, at least has that built into it. If you can't find it, it's usually near the LN button that actually says LN, or try looking near the LOG button. Here's a common question. 1,200 is invested at 2.65% compounded monthly for 5 years. How much is left after that time, and then how much interest is paid? And here's the equation filled out. Again, following my general compound interest formula, I have 1,200 times the quantity, 1 plus R, 0.0265 over 12, raised to the 12 times T power, 12 times 5 for 5 years. When you do the math, an estimation is 1.0022808 after dividing 0.0265 by 12 and adding 1. Then we raise to the 60th power, multiply times 1200, you get approximately 1369.79. So that's how much is left. Now the next question, how much interest is paid? Remember, interest, of course, is what's paid beyond the initial amount. So this formula that we use includes, because it has a little plus 1, it includes the initial $1,200. So to find that interest, we'll say whatever our final amount is. Now this is an estimation, and you can see how many decimal points I went out. I'd say a good estimate would be about 4 or 5 decimal places. But if you had 1370, for example, maybe 1368, you're within $1 or so. I'm not going to make a big deal out of it. This is why I encourage you, when you can, break it down as much as you can, and whenever possible, try to show your work. So I'll subtract my original amount invested from this, and that leaves me with 169.79 interest. This is the way you approach any common compound interest formula. The main thing is to understand how to approach how many times it's being compounded. In this case, $1,000 is invested at an account that compounds daily at 3.5%. After 80 months, how much is left? Now it's daily, so our N is going to be 365. After 80 months, now the difference here is, the last ones I've been giving to you are in terms of years, so we need to figure this out in terms of years. So the first thing I'll do is figure out how many years are in 80 months. So divide my 80 by 12 to get approximately 6.666 repeating. Now I can put that into my formula. So here's our equation. In the following format, we have 1,000 times 1 plus the rate 0.035 times, divided by n, which is 365. Raised to 365 times. Then in years, since we're talking about 80 months, we have 6.666. That took 3 decimal places. Years, that is. Doing the math, we get about 1.00095 to the 2,433 power. When you do the math, you get around $1,260.03. And then finally, to use the continuous compound interest formula. As you see here, the common question is when it specifically asks for a continuous compounding. That's where we use our A equals PE to the RT power formula. So using our formula, A equals PE to the RT power, we have 950 times E to the 0.04 times 6 power at 4%. So again, we have 950 times E to the 0.24, and we do the math, again, using our order of operations. Do E to the 0.24 first, and then multiply times 950, which gives you about 1,207.69. And again, to calculate our interest paid, we subtract the original amount from our from our 950. And we'll get about 257. for the amount of interest paid. Now, one of the last types of problems that we'll go over is where we're trying to find what the book will often refer to as the present value. In other words, we're trying to find our principal. So after 5 years compounded quarterly at 3.8%, an account has reached $23.75. How much was initially invested? It's my dog in the background. He's shaking. So again, this time we're going backwards. We're going to say we know what the final amount is. We need to know the initial amount. This becomes more of an algebra problem. So again, using our compound interest formula, I'm working backwards. I'm trying to find P now. So we ended with $23.75 after 5 years compounded quarterly. So my N is 4. And as I said, I'm working backwards. So I'm going to find out what is 1 plus 0.038 over 4 to the 20th power, which ends up being 1.20816 approximately, times our p-value. Then it becomes an algebra problem. I divide each side by 1.20816, and I get approximately 1965.80 for my initial amount. Then lastly, Emily purchased a bond valued at $20,000 for highway construction for $9,420. The bond pays 7.5% annual interest, compounded monthly. How long must she hold it until it reaches its full value? So the difference here is the previous question we were asked to solve for a principal. This one we're being asked to solve for a time. When we're asked to solve for time, typically this is when we use our logs that I referred to earlier. So I'm still going to use the same compound interest formula, enter in the values that I know, and then we're going to end up solving for a exponent. So understanding this problem means that we're going to set up the compound interest formula. Again, putting in what we know. We have 20,000 is our final amount. Our principal is 94.20. Rate is 0.075, and 12 is the it's compounded monthly, so 12 is our n. T is the unknown. So we'll just continue to simplify what we can. So I get 20,000 equals 94.20 times 1.00625 to the 12t power. Now in a problem like this is a very specific one. So when we solve for an exponent, we want to isolate the exponential itself. In other words, I want to isolate the base of 1.00625, which means I have to divide each side by 94.20. That gives me about 2.12314. Now what happens is, this is where our log comes in. As you can see, what I've done is after I divided 20,000 by 94.20, I took the log of each side. Now if you're not familiar, on your calculator you should have a log button, the LOG. And just as it is, you type in, as you see here, log of 2.12314, and then to balance it, I took the log of the other side. And for those of you familiar with log bases, we'll just take the standard log base of 10, which is programmed automatically into your calculator, so you won't need to do anything. Now the effect of taking log of both sides is it makes anything in the exponent position, in this case the 12t, come down out of the exponent spot in front of the log. So it comes out to be this now. Log of 2.12314 equals 12t times the log of 1.00625. So then to solve for t, my 12, and my log of 1.0065. Now, even though it's complicated looking, all it is a number. So I'm going to treat it like a number. And to isolate my t, I'm going to divide it by 12 and that log of 1.0065 at the same time. And you can see it gives me this. So I've divided both sides by 12 log of 1.0065. Gives me this equation. And when I do the math, I end up with about 10.07 years. And again, make sure you use the proper units. So again, log is used when you're finding unknown exponents, or in this particular case, unknown time. This concludes section 9.2. As always, if you have any questions, feel free to contact me.